My grandfather was a machinist and worked as a tool and die maker for 30 years. He was not classically trained, but he had a real knack for figuring things out. Solving problems and making the solutions often extended into his personal life. So it was a natural progression that he built out his own personal machine shop. And that's where all of this comes from. Every tool in this shop belonged to my grandfather. Well, every tool except for one. This tiny machinist hammer. Turns out that my wife's grandfather was also a lifelong machinist. He took the more traditional path through a formal apprenticeship starting at the age of 16. And this hammer was one of the first projects he completed through that schooling. It also happens to be the only machining-related heirloom that was passed on to my mother-in-law, which she's now passed on to me. I was incredibly honored to be gifted such a unique and personal item, and it honestly made me consider the value of making one myself to pass on to future generations. So I did just that, and of course I had to put my own twist on it. The typical machinist hammer is made from multiple pieces that are either threaded or press fit together. But I'm going to take a more challenging route and make it as a single piece. I spend enough time at the computer in my day job, so I'll be doing this the old-fashioned way, with a drafting table. The drafting table surface is covered in a thin sheet of vinyl that makes it smooth for drawing. And there's a nifty device called a drafting machine that'll hold a set of scales at a desired angle across the entire table. I'll start off at 0 degrees and use the edges to align a piece of vellum. Vellum is just a fancy name for the semi-transparent paper that is typically used in drafting. These adhesive dots in the corners hold the vellum flat and prevent it from moving around. Before I start, I need to determine which views I'll need and the appropriate scale for the drawing. The original hammer is about 7.5 inches long. That will fit on this sheet, so I should be able to get away with a 1:1 scale. And since there aren't a ton of complex features, the standard 3 views should be plenty. On to the drawing. I typically start with a hard lead and gentle pressure, which leaves a fine, light line. This allows me to erase easier as I make changes and adjustments. Selectively erasing lines can be tricky though, so I normally use an eraser shield, but I seem to have misplaced it. They look like this and are basically a thin stencil for an eraser. There are a variety of actual drawing stencils. None of these are strictly necessary, but they help speed up the process. I find myself using the circle one the most for small diameter features that would be difficult to draw with a compass. Though a compass is still needed for the larger radius arcs. I typically just use the drafting machine scales to set the various radii I need. And the soft vinyl top gives a good surface for the compass needle to sink into. The head of the drafting machine has detented positions for common angles, and any other angle can be set accurately using the vernier scale. Even with the ability to set the head at an angle, it's still sometimes useful to keep the common triangles nearby. They come in handy when you need one quick short angle, like a chamfer. Once I'm happy with the design, I switch to a softer lead and darken all of the final lines. And in the case of the compass, I just press harder. The last step is to add all of the dimensions. There's honestly a whole separate art to dimensioning, but in general, you want to keep all of these neat and orderly, sharing common data points, and only showing the minimal number of dimensions to convey all the measurements. However, as I'm designing, I'm also considering the process which I'll use to ultimately machine the part. This is a whole other subset of engineering called design for manufacturing, and it includes considerations for tooling, fixturing, and the sequence of material removal. So I often include additional and redundant dimensions that are more relevant for those particular setups. Another stencil keeps the arrowheads on the dimension lines consistent, although I sometimes opt for doing a faster freehand if I'm growing particularly tired of holding a pencil. There are stencils for the letters and numbers, but these honestly would be a nightmare to use. So most draftsmen are trained to freehand these as well in a consistent font and size. It's actually quite odd going through this lesson in a drafting class, printing out the letters of the alphabet one by one like a kindergartner, but it's a skill that ends up sticking with you like riding a bike. Last but not least is to add the name and date. This will tell me who to track down if I have any issues. Alright, that's enough time sitting. Let's make this thing. Like I said before, I'll be machining this from a single piece of steel. I would ideally like to make this from 4140, but due to a lack of planning, I'm stuck with what I already have. A hot rolled low carbon steel. The raw stock isn't even remotely square, so the first step will be to mill each of these faces flat into a known dimension. Since there's so much variation in the surface, I've learned it's helpful to use a rod of aluminum on one side when clamping this in the vise. This first pass should be deep enough to just clear the oxidized surface. Going any more than this and we'll start eating away at the size of the hammerhead. Then we can flip this over and mill the second side parallel to the first. Again taking off the bare minimum. The next two sides are basically the same process, except we'll remove a lot more material. The largest diameter feature is only 5/8 of an inch, and this stock is 1 inch thick. So we'll mill this down to a thickness of 3/4 of an inch. And get this as close as we can to that measurement, since these faces will be used to indicate this on the lathe in future operations. We'll finish squaring off this block by side milling the ends. And since the material is longer than the vise jaws, we can do both ends in one setup. Sometimes it's the little things. At this point we could theoretically mount this in the lathe and start on the detail work, but we would just end up turning away most of the material. So while this is still set up here, we can loosely cut out the T-shape of the hammer. I initially tried side milling at full depth into the material, but it chattered like a mofo. I quickly realized that taking incremental plunge cuts is way more effective. The end mill seems to relish cutting like this. Before I cut away the rest of the material around the handle, I need to center drill exactly in the middle of the end that will make up that handle. This will be used for tailstock support when we finally get to the lathe. Actually, the lathe is just one step away. Rather than mill away the remaining material around the handle, we'll just cut it off with a bandsaw. This leaves pretty sizable offcuts that might be useful for another project. Now we can start the much anticipated lathe work. The stock doesn't have a single round feature on it, so we'll need the 4-jaw chuck. The jaws are independent, so I can adjust these until the part is roughly centered. Then support the far end using the center drilled hole from before with a live center. I'll finish aligning the material in the chuck with the dial indicator. This is the real reason for milling everything square. I can use all these known faces as references to indicate on, and adjust the jaws until the lowest readings on opposing sides are the same. Alright, let's make some chips. I've never turned something square down to something round, but I've definitely seen it done before. Regardless, I'm being a little cautious since I don't want to overload the tool or cause the material to work its way loose. Okay, maybe that's a little too cautious. Let's take some deeper cuts. The diameter of the gripping part of the handle is a 1/2 inch, so I'll turn the whole length down to this size. Then we can switch to the knurling tool. And I've learned I also have to change to a smaller live center for the clearance. I really only have one set of knurling rollers, so I'm kind of stuck with whatever this makes. I have noticed, however, that this tool will produce different results depending on the starting diameter. It will either make a knurl the same pitch as the cutter or double the pitch of the cutter. Looks like this one will be a single pitch, which is fine, I guess. We can now finish turning down the stem of the handle to the smaller diameter. The transition between the stem and the knurled handle is a short 10-degree taper, so I'll set up the compound rest to cut this. The last cut of this setup is to make the fillet between the head and the stem. So we'll grind a form tool to do this. I'll need this cutter for multiple operations on this part, so I'm considering clearances for those as well as I'm grinding. The geometry probably isn't ideal, but I only have a few cuts to make with it, so let's give it a try. I'm mounting this at a slight angle in the tool holder with a decent but acceptable amount of stick out. This will help me reach into the area I need to cut, but also actually let me see what I'm doing. Okay, so far so good, but the deeper I go, the more talkative the tool gets. Maybe a different speed will work. That vibration is more intense, but the chips are better, so let's keep going. Geez, Brandon, calm down. What's the problem? Oh, yeah, that's no good. Those vibrations I mentioned? Looks like they caused the tool setup to drift, and it dug away at the spindle. If I try to finish the hammer now, it'll have a weak point in pretty much the worst possible spot. I guess I'll be starting over. But before I do that, let's get to the root of the problem. That chatter was most likely a result of tool geometry. So I'll grind a proper cutting angle on this thing. Hopefully this compound angle will do better. This time around I'm going to keep the tool as close as possible to the tool holder, and also give the tool post locking nut the beans. Okay, that is so much better. Consider the lesson learned. Don't take shortcuts and lose hours of work. At least the second time through should be a lot quicker. Alright, we're back to where we left off. I did make a few aesthetic changes along the way though. After seeing how spindly the stem looked, I decided to beef it up a bit. I also got rid of the 10-degree taper on the handle. This more aggressive transition just looks way better in my opinion. Lastly, and definitely not a result of any sort of skill, I managed to get a double knurl pitch on the handle like I originally wanted. I have no idea how I did this, but I'll consider it a good sign and keep moving. Now let's take another stab at that fillet. I'm feeling a lot more confident now that we know why it didn't work the first time around. That came out perfectly, way better than the first attempt. And we won't talk about how close I was to cutting into the chuck jaws. Before breaking this down, I'll cover the lathe ways and sand away all the tool marks with emery cloth. So far, this is looking great. I no longer need the center drill in the end, so I'll cut this to length now. I want the end to have a radius on it as well, so I'm using a form tool I ground back when I made the tap wrench. It acts as both a parting blade and a radiusing tool at the same time. It doesn't exactly leave a nice finish though, so I'll flip this around to the lathe and sand it smooth. Now for something a little more thrilling. To turn all the features on the head, I'll be mounting the hammer 90 degrees in the chuck. As in, the handle will be whipping around at a great deal of speed. This is actually why I went through all the extra trouble to mill all of this square. It gives me something to not only hold on to, but also to indicate off of like before. Before I go turning this on though, I need to make absolutely sure I have clearance for the handle all the way around. I 100% didn't think about this ahead of time, but I literally couldn't have made this handle any longer. It just barely clears the saddle casting. That could have been really bad, so I'm glad I checked. I'm expecting to have to counterbalance this somehow, but first let's see how bad the imbalance is. On second thought, I think that should be just fine. I'll turn the cylindrical side of the hammerhead first. This will ensure I have something substantial to hold on to when I flip this around and cut the ball peen side. To cut the next feature around the center of the head, we'll remount the filleting tool we made before, again reducing the stick out to an absolute minimum. The depth of this cut is really only for appearances, so I'm taking it just far enough to intersect with the first fillet we turned. And one last thing before we flip this around. Nice. I was going to cut the ball peen side next, but it occurred to me that it might be a better idea to work on the middle features before I cut away all this square fixturing material. So it's over to the mill. The middle section is currently square, and I want it to be square, just a smaller square. So I'll mill down both sides and the top. I'll have a matching fillet cut on the ball peen side, so I only have to mill far enough to intersect with that. I also want a nice chamfer on the top two edges, so we'll switch to this insert tool for these. All of a sudden this is starting to actually look like the head of a hammer, and we're getting really close to the finish line. To cut the ball peen side of the head, we'll switch the 4-jaw chuck out for the 3-jaw. This saves me the step of having to indicate the head end with independent jaws. And the aluminum covers protect the finished side from damage. Turning this down is the same as the other side. Then we can switch to the filleting tool once again and cut just far enough to intersect with the stem fillet. The last and final features to cut are the curved profiles that give the ball peen its name. I have two different radii to cut here, and I could make a form tool to do this, but honestly they're completely aesthetic, and it would take me way longer to grind the form tools than it would to just freehand turn something. So that's exactly what I'm going to do. That looks about right. To smooth out the profile, I'll very carefully use the end of a file, and also very carefully sand the curves smooth with emery cloth. Then that's it. The single piece tiny shop hammer is complete, and I think it's a mighty handsome tool. Sure, it's just a hammer, but it's a hammer that I made, and one that I'd be proud to pass on to my grandchildren, just as these tools were passed down to me by my grandfather. I will be adding a maker's mark, but I don't want to just stamp my initials on here willy-nilly. My personal standards simply won't allow that, but I'm sure I'll come up with something soon. As always, thanks for watching and see you next time.